You are with Professor Solis and Strategies for Success. So today we're going to talk about the real number system. So we are going to write the capital R. Well, it's actually a double R. I put a line in there. And that is the symbol for the real numbers. We're going to branch off the real numbers into two types of numbers, rational numbers and irrational numbers. So let me make sure I print this nice and neat so you guys can write these down in your notes. And then our symbol for rational numbers would be capital Q. We don't have a symbol for irrational, so all we do is abbreviate IRR period. IRR period. Then under rationals, we have integers. We heard about integers through our school days in K through 12. And we use capital Z for integers. Under integers, we have our whole numbers. Our whole numbers, we use the symbol capital W. Oh, forgot my little line here, y'all. And then under whole numbers, we have our natural numbers. Under natural numbers, our symbol would be capital N. And what we want to do with our flow chart, we want to make sure we can write examples for each one of these. I use I.E. This means I'm about to share some examples. So hopefully you'll remember that as we do some of these. So examples for natural numbers would be 1, 2, 3. I would use 3 dots. That means it continues to go on to positive infinity. We'll use the infinity symbol. Hopefully you draw yours a little bit better than mine, but we don't need that plus sign because we know it's going in a positive direction. Natural numbers flow into whole numbers, which start at 0, 1, 2, 3, and those numbers go on to positive infinity. And then whole numbers are inside of integers. Integers go from negative infinity to positive infinity, but we want to put more examples specific there. So we'll say 1, 2, 3 dots. We'll use some negative numbers. We'll use 0, and then we're going to move this infinity symbol down a little bit, and we'll put in our positive numbers, then our 3 dots, and to positive infinity. So integers, think about a number line. And then integers flow into rational numbers, which rational numbers could be a perfect square root. So a perfect square root would be like the square root of 36. In case we forgot that, let's go over here to the side. So square root of 49. If I pulled out that's a perfect square, it would be 7 times 7 under the radical, and then you can pull out a pair of sevens, which would just equal 7. So that's what we call a perfect square root. So square root of 36, I could do the same thing, and that would be 6 times 6, pull out that pair of 6, and you count it 1 time. That's how we get 6. That's what makes it a perfect square root. Then think about that symbol Q. Think about quotient. So those would be fractions. We can say 3/4. Another example of rationals would be decimals. Let's say 4.8. And then, of course, integers can also be written as a rational. So everything in the integers is up here also. Then let's go over here to irrationals. Irrationals would be non-perfect square roots. Square root of 37, that'd be a decimal. The base E symbol, 2.71, in case anyone remembered that, or we could put in the calculator later. And then the pi symbol, 3.14. So these are good examples for our real number and our different categories. So let's kind of do a little summary here. So natural numbers, 1, 2, 3 to positive infinity, flow into whole numbers, 0, 1, 2, 3 to positive infinity, flow into integers, negative numbers, 0, positive numbers, flow into rationals, perfect square roots, fractions, decimals, and then our irrational numbers, square root of 37, non-perfect square roots, base E, pi symbol. All of these numbers are part of our real number system. And we'll break these down more, but we'll use all these types of numbers in our college algebra course. So thanks for listening, and we will join Professor Solis for our successful strategies in future videos.